morning, students. Today we will have to discuss the next part of the principles of inheritance and variation. In previous lesson, we have discussed about the test cross, and we have discussed that what is the significance of test cross. Test cross is to know the genotype of the unknown parents. But today we will have to discuss about the next point. Two other type of test cross. One that is called back cross, and secondly that is called reciprocal cross. These are the another two types of the test. Now, in back cross, the significance of the study of the back cross is to improve the breed. Suppose this is the heterotrophic, not homozygous but heterozygous, and this one is the homozygous recessive. If you will have to improve this recessive to dominant, then what happens? We will cross it with the capital T, and we can get the heterotrophic or dominant type present. This is one of the example of the back cross, and in this way we will see that we can improve the breed. But in the case of reciprocal cross, what happens? Suppose A is crossed with the B, and the male part of the A will be retained and the female part of the B will be retained. Then their gametes will be A, their gametes will be B, and their odd product are B. But here A is the male part and B is the female part. But if you consider same A into B, and if you consider the female part of the A and the male part of the B, and this is called reciprocal cross. This type of cross is made to confirm that the male and female is not responsible for it, but the progeny is responsible for the dominance of the recessive. Now, the next point of this inheritance, principles of inheritance and variation, is the variations from Mendelian principle. Mendelian principles. It has been observed that Mendel performed experiment by selection of pure plant. Second, cross between these two pure plants, that is the dominant and recessive, both should be pure. Recessive is always pure, but dominant may be pure or habit, but we will consider only dominant. Mendel has do this particular perform. And thirdly, that is called selfing of F1 product, And it has been observed that during monohybrid cross, the ratio is 3:1, and with dihybrid cross, ratio is 9:3:3:1, and that is the phenotypic ratio. It has been discussed in the previous chapter, previous lecture, and we have discussed how to get the genotype. Now today we will have to discuss that if this ratio is not there, then what we mean, and that is called variations in the Mendelian principle. Now, first of all, you must know that suppose this one is a pair of chromosomes, and having this is the factors present on this. It is called loci. It is called loci. Another, suppose this one, and having P, that is purple and white. If cross between these two, it is called intrazenic cross. Intrazenic cross. And in the variation of the Mendelian principle, in intrazenic cases, that is called epistasis and polygenic. We will discuss it in detail with the help of this example. That is called polygenic inheritance and the epistasis. But if the cross between these two, one loci and the loci is two, then it is called interzenic. Interzenic. And there are certain examples of the incomplete dominance, codominance, and in both the cases it has been observed that 9:3:3 ratio or 3:1 ratio is not being seen. Now, with the help of example, firstly we will discuss the incomplete dominance. The certain example that is called 4 o'clock. The same in the dog flower. It has been observed in the 4 o'clock plant that red flower, when crossed with the white flower, according to Mendel's law, if it is dominant and if it is recessive, then their product is this one, and it should be red. Due to law of dominance, according to Mendel, the law of dominance says that if any of the factor is dominant type, their character is dominant type, and this red is the phenotypic character, so it should be red. But it has been observed that in this case, it is not red, but it is pink. It means this recessive character is not completely suppressed by this dominant. And we can see when we cross it, when the selfing of the F1, then we can say that these two characters will not intermingle. but are lie side by side. And whenever they get a chance, they appear. Now, in the F2 generation, what happens? The R should cross with the R. That is the hybrid. This one is hybrid. Both are not pure. And here they are the F1 product. Then what happens? Their gametes are capital R, small r, capital R, small r, and when they cross, they will produce R, and R. This type of ratio had been seen, which will be observed in the case of Mendelian principle in the monohybrid at the time of 1:2:1 ratio, that is a genotypic ratio, and their phenotypic ratio is 3:1. The same thing is here, 1:2:1. One that is called pure dominant, 2 that is hybrid, and 1 that is the pure recessive. The same thing, 1 is pure dominant, this 2 is the hybrid, and 1 is the pure recessive. It means their ratio is 1:2:1, but the 1 is the red, 2 is the pink, and 1 is the white. It means genotypic ratio is similar to the phenotypic ratio, and this is not following the Mendel's principle. It means this character, this dominant factor, is not in condition to suppress completely, and at the time of formation of the offspring, they are not completely intermingled, they are not mixed, because at the time of gametization it had been observed both become separate to form the white also. So we can say that this is the one of the example. The same thing in the case of dog flower also. It has been observed that this type of ratio is also observed in the dog flower. In animal, that is the adulation form. It has been observed that the black adulation form, that is the case of the bird, when crossed with the white, not completely white but bluish white, and it has been observed that the white is recessive, this one is the dominant. Their cross is not white but blue. It means this particular white is not completely suppressed by the black, and that is blue, and this is the F1 product. Now when F1 product, that is called BB cross with the BB, their product should be BB capital B small b, small b capital B, small b small b. According to Mendel's principle, all should be black and one should be white, but it has not been observed in the case of the adulation form. It has been observed that only one black and these two are the blue and one is white, so their ratio is 1:2:1, and this is the genotypic as well as phenotypic ratio. So this is the one of the variation in the Mendelian principles. Now in next lecture we will discuss about the codominance, which is also the example of the variations in the Mendelian.